So section 3.2 is going to take a few applications of radian measure, and we're going to apply them to questions that have like real life application. But the first major application of radian measure is arc length on a circle. So all of these questions are going to be asking you for arc length. Now, an arc of a circle is the part of a curve contained by a central angle. So what I mean by an arc is if you have a circle right here and I wanted the arc between like 0 and pi over 2, I'm asking for the distance curved around that circle, kind of like your radius distance that you had to curve on your picture for today. That's an arc length. Now there's a formula for arc length, which may pop up on a formula quiz next class. It says that the length, I don't know why that just went away. This is what I highlighted. I don't know why it disappeared. The length S, so arc length is represented by the letter S. The length of the arc intercepted on a circle of radius r, and a central angle of measure theta in radians is given by the product of the radius and the radian measure. So basically, arc length is equal to r times theta. But make sure you notice that in this formula, theta has to be in radians. This formula does not work if you're measuring in degrees. So this is why it becomes an application of radian measure, and we never talked about it with degrees. This is for radians only. So if we're just straight up using this formula, it says finding the arc length using the formula S equal to R times theta. I highly recommend writing out what you're given in the problems so that you know what you're solving for. Part A says a circle has a radius of 18.20 centimeters. So I know that I have a radius of 18.20 centimeters. It wants me to find the length of the arc, S, intercepted by a central angle having each measure. So in part A, our theta is 3 pi divided by 8 radians. So if we're going to solve for S, S is just simply R times theta, which means we're just plugging these numbers in. 18.20 centimeters multiplied by my radian measure, 3 pi over 8. At this point, it turns into a calculator question. So you're going to actually use the pi button on here. Well, first of all, make sure your calculator is in radian mode. It should be, because the class before you is using radian mode. But just in case, 2nd plus 712 puts your calculators back into radian mode. And then we'll go ahead and do 18.20 multiplied by 3, use the pi button, divide by 8, and we'll round to 4 decimal places, please. We should eventually get that the length of this arc is 21.4414 centimeters. Now, something that's semi-important to point out for you is because we're going to be answering with units for the most part today, and if you're thinking about units, you're probably thinking, wait a second, we multiplied two things that are measured differently together. We measured centimeters multiplied by radians. Now, normally, when you multiply like centimeters times centimeters, it becomes centimeters squared. Or if you multiply meters times seconds, it would be like meters times seconds. Like that would be the unit you use. When you're measuring arc length, it still just ends up being centimeters, which means when you're using a unit of a radian, it kind of like disappears. You don't include it in the final answer for this since it's a measurement of a distance. When we end up doing speed, angular speed and linear speed, there will be radians in your units, but that's because it's a radian per second. So radian would be by itself on top. When you're multiplying times radian, you let the radian unit just go. It's just in centimeters. Kind of extra information, but important in case you were wondering. Let's do the next one. It says this time our R is still 18.20, so we haven't changed the radius length in this problem, but theta this time is 144 degrees. Now, annoyingly, you do need to put this degree symbol right here, because if you just put 144, you've told me 144 radians. This indicates that we're using degrees. But I did tell you that this formula can't be used unless you're using radians. So we're going to have to translate this into radians, which based on what you did on your quiz today, hopefully, you said that the conversion would be multiplying by pi over 180. This we can do in a calculator, but you're going to leave off the pi because we just want the fraction. So you would do 144 divided by 180. You'd end up with 4/5. So you're going to say 4 pi over 5. That's just the reduced version of this angle. Yes, so leave the pi in radians. But when we go to do our arc length, S is equal to R times theta, so we can just plug these numbers in. Again, that's 18.20 multiplied by 4 pi over 5. This one you would use the pi button because we're not leaving it in terms of pi. And again, fast forwarding through the math because I trust we can do that part. It's 45.7416 centimeters. So the main idea here is even if I give you degrees, when you're finding arc length, it has to be in radians. So you will have to translate it to radians before you plug it into your formula. Check. Is that fine? Okay, let's apply it to a bigger problem. So latitude gives the measure of a central angle with a vertex at the Earth's center, whose initial side goes through the equator and whose terminal side goes through the given location. Reno, Nevada is approximately due north of Los Angeles. The latitude of Reno is 40 degrees north, and that latitude of Los Angeles is 34 degrees north. We said that. The radius of the Earth is 6,400 kilometers. Find the north-south distance between the two cities. We are trying to find, if I zoom in on this picture, we are trying to find this measure of the arc. We know that the angle between these two cities is 6 degrees. How did they get 6 degrees? 40 minus 34. So you had the latitude of Reno and the latitude of Los Angeles. We subtracted them to find the angle between them. We also know the radius of the Earth. The radius of the Earth is 6,400 kilometers. So we actually have enough information to find this arc length between the two cities. So let's list out what we know just to make sure we have everything. The radius is 6,400 kilometers. And my theta is 6 degrees. Do I plug it in right now to my formula? No, because we cannot plug in degrees, we have to plug in radians. So we're going to take 6 and we're going to multiply it by pi over 180. This one's easy to do in your head. 6 pi divided by 180 would simplify down. How many times does 6 go into a 180? 30, so it's pi over 30. Again, that's just 6 divided by 180 and simplified down, which means that the arc length between the two cities is r times theta, 6,400 kilometers multiplied by pi over 30. Now that it is in radians, we can throw it into a calculator. 6,400 multiplied by pi symbol divided by 30 would be about 670.2064 kilometers. That's about the distance between the two cities. Pretty easy formula to use, right? Really the only trick I can give you is if I give you the angle measurement in degrees instead of in radians, you just have to remember to translate it to radians. Okay, on the back we have a few more applications of radian measures. This first problem is says a rope is being wound around a drum with a radius of 0.8725 feet. The figure is there for you. How much rope would be wound around, why is that so hard to say, the drum if the drum is rotated through an angle of 39.72 degrees? So I'm asking how much rope would be used, the arc length, if the radius is given and the angle measurement is given. This is the same formula. Again, I like writing down what I'm given just to make sure I have enough information. The radius is 0.8725 feet. The angle measurement is 39.72 degrees. And my spidey senses go off that to find arc length, that needs to be changed into radians. So I multiply that times pi over 180. And just for ease, we're going to leave it as 39.72 pi divide by 180 for this problem. Just because that's a decimal, don't love that for myself to reduce by hand. So we're just going to leave it like this. So when we find the arc length, the amount of rope that has wound around the drum, the arc length, why did I put R? I'm so sorry, that should be S. The arc length is equal to R times theta, which is 0.8725 multiplied by 39.72 pi over 180. Beep, 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 bop. Calculate in our calculator. especially with that decimal and the pi. And since I have to answer the phone, you'll go ahead and do that for yourself. End up being approximately 0.6049 feet. Is that what you guys got? Yes. Fabulous. Okay. Now the next problem is going to be a little bit more challenging, but if we set it up the way I've been setting up the questions, it actually makes a lot of sense. It says 2 gears are adjusted so the smaller gear drives the larger one, as shown in the figure. So we're moving this guy, and it forces this guy to move. That's how gears work. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger gear rotate? So this problem has 2 parts, so I'm going to do the parts separate. The end goal is to answer the degrees of the larger wheel. That's our end goal. To be able to answer that, we need to know, I keep writing those numbers backwards, we need to know the arc length and the radius of the larger circle. What do we know so far in this problem? Do we know the arc length for the larger? I'm going to put little bitty L's underneath all of these so we know I'm talking about the larger, the purple gear. Do we know the arc length that the gear has moved? No. Do we know the radius of the gear? Yes. Yeah, we know that the radius of the gear is 4.8 centimeters. But I don't have theta for the larger wheel, and I don't have the arc length for the larger wheel. So before I can solve for theta, because we're looking for this guy this time, I need to go back and figure out the theta for the smaller wheel, or the arc length for the smaller wheel. So if we go think about our smaller one, we know that the radius of the smaller guy is 2.5 centimeters. We know that the theta of the smaller guy is 225 degrees, which if we do a quick little calculation, it would be 225 pi over 180, which does reduce to something nice. It's 5 pi over 4. So I know the angle that the smaller one is moving, which means since I have r and I have theta, I can find the arc length that the smaller guy is moving. It's just going to be r times theta, which would be 2.5 multiplied by 5 pi over 4. Beep, 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 bop. We would get, I left this one in terms of pi, just so we don't have to round our number. It's 25 pi over 8. Remember, you don't want to round a number in the middle of a problem, so you don't press the pi button in the middle of a problem, you would press it at the very end. Now here's the deal. The arc length that the small gear has moved, the amount of distance, since those teeth of the gears are interlocked, will be the same distance that the purple one has gone. So what we can do is we can use this value, the small arc length, as the same one for the large arc length. So in this problem, I now have the large arc length, because it's the same. I now have the radius. Can I solve for theta? Yeah, if I just take this equation right here and I just solve it for theta, it would end up being theta is equal to S divided by R. Well, that arc length is the same arc length as the small guy, and we're just going to divide it by the radius. Well, the radius of the big guy is 4.8. At this point, I would assume most of us would choose to throw that into a calculator. We are trying to find a final answer at this point because we're looking for theta. We're looking for this larger angle. So we can just throw that into a calculator. Yes, it's a fraction within a fraction. If you're doing it by hand, you would keep, change, flip. But at the end, we're going to be doing a calculation anyway. So if we evaluate this, throw it into a calculator, we would do 25 pi over 8, all divided by 4.8. We should get 117.1875 radians. Wait, I think I just said everything wrong. Hold on. Okay, big lie. Let me back up for a second. Just erase the final answer we wrote. Everything we put here is fine. If we do this in radians, you should get 2.0453. Is that what you guys got? Now, before you lose this number out of your calculator, I also want to write this answer in degrees. because there is an opportunity that it might ask you to put the answer back in degree mode. So what do we multiply this number by to put it into degrees? 180 over pi. So in your calculator, before you lose this number, just immediately press times 180 divided by pi so that it's taking your answer. I just hit the wrong button. So it's taking the previous answer and multiplying it by that factor. That's when we get the 117.1875 degrees. So if you answer in radians, which is what we're getting out of this formula, but the question itself needs the answer in degrees, you just have to multiply by 180 divided by pi to get it into degrees. Just depends on what the question is asking for. Okay, last little bit here is a new formula used the same way. So when we were finding the arc length, we were just basically finding a piece of the circumference of the circle. But we can also find the area of a sector of a circle. So if I was finding area or a sector of a circle, it would not just be the circumference, it would be the entire area in between two angle measurements or around a certain angle of your circle. This formula is a little bit different. It's area equal to r squared times theta divided by 2. So it's squaring the radius, which makes sense to me since area is usually is always 2 dimensions, so we're squaring the radius. And then it's just theta divided by 2. So an example that uses this formula says a center pivot irrigation system provides water to a sector-shaped field with the measures shown in the figure. Find the area of the field. Okay, let's see what the figure gave us. It gave us that this right here is 321. What did they give us right there? Radius. So our radius is 321 meters. Then it also gave us this right here. What is this? Theta. So they gave me a theta, but they gave me theta in degrees. So before I use it, what do I have to do? Put it in radians. So this would be 15 pi divided by 180. This does simplify to something nice. It's pi over 12. So at this point, I have everything I need because to solve for area, I only need a radius and a theta. It is the radius squared times theta all divided by 2. If we fill all of that in, that's going to be 321 squared multiplied by pi over 12. And then all divided by 2. As long as you make sure to put that theta into radians, beep, 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 bop, you just fill in what you know and you solve for the area, which should be a large number, 13,488.0354 meters squared. And if that's true, that is a very powerful irrigation system. Because in my mind, this was like a sprinkler in a yard, and if it's covering that many square meters, it must be real powerful. Okay, I do want to go over one last thing before we finish. So on the problem, number 4, I can imagine online homework asking you to write your answer in terms of pi. So in questions that say write your answers in terms of pi, if you see that, that means it wants the pi in the final answer. So if I were to take the problem we had when we were finding the theta for that large circle, we had 25 pi over 8 divided by 4.8. And if it had not asked for just radians, or if it had not asked for just degrees, but it says radians in terms of pi, here's what you would do for this problem, just in case your homework asks for this. This would be one you have to sort of do by hand. You keep the top fraction, you change the big divide to a big multiply, and you flip the denominator, where this ends up being 4.8 over 1. Is that true? Hold on. Big lie. I have to actually flip this number. We flip it. Keep, change, flip. Then we can do top times top and bottom times bottom. So if we do this, this would be 25 pi times 1, which would be 25 pi, over 8 times 4.8, which is 38.4. If, there's a lot of ifs here, if this is not accepted, because it is an answer in terms of pi, but you have a decimal in the denominator, which again, I'm not sure if the book will accept or not, because some of you get decimal numbers, some of you don't, since they're all different questions. We would have to actually take the number 25 divided by 38.4 and frac it in a calculator. When you do that, you end up with an answer of 125 pi over 192. These are equivalent. They're the exact same. I'm just not sure if the book is going to accept the top one or the bottom one. Does that make sense? Yes. So keep, change, flip is what we're doing. And if it doesn't like that answer because you have a decimal somewhere, put it in your calculator and make it a fraction, and it will make it a like the least common fraction with no decimals in it. But if it doesn't ask for in terms of pi, the two answers we wrote on the other page would be fine. In terms of pi is when you have to do stuff like this. Cool? Yeah. Okay,